So we're on chapter 4.6, rational functions and models. So our goal here is to identify a rational function and state its domain, identify asymptotes, interpret asymptotes, graph a rational function, and using transformations and rational functions by hand. All right, a rational function. So basically what a rational function is that you have a variable in your denominator, okay? That's what makes it a rational function, is that you have a variable in the denominator, okay? And what can your denominator not equal?
Zero.
A zero, okay? So your denominator cannot equal zero. So remember, it is okay for zero to be in the numerator, but it's a no-go for zero to be in the denominator. You get it? All right, so when we're looking for what's called discontinuities, we're taking our denominator and setting it equal to zero. And that's going to tell us where our discontinuities are. So for example here, is this determine if the function is rational and states its domain. First check, is there a variable in the denominator? Yes, there is a variable in the denominator, that guy right there. So this is a rational function. Variable. And we have a variable in the denominator. We do. All right. So then now you're going to find your domain. To find your domain, you have to figure out what makes your function equal to zero. So your domain, we would take 1 minus x squared and set it equal to zero. Okay. I like to put not equal because that's what you're looking for, is where is that discontinuity. So for me, I like to put the not equal symbol just so I remember that this is a point that can't be used. Okay. All right. But we're clearly setting equal to zero. So our goal is to get x squared by itself. So I'm going to subtract 1. And we're left with negative x squared equals negative 1. We divide. So we know that x cannot equal positive 1 or negative 1. So our domain is x cannot equal positive 1 or negative 1. And we're going to write that in a little more scientific way, not scientific, mathematical way. Hold on. We're going to write it in set notation and in interval notation. So in set notation, we're saying that our domain is, I suck at drawing brackets, so we're going to pretend that's the world's best bracket you've ever seen. I need sleep. That our x exists, that e, this little e merged with the c means exists. And all real numbers such that, this is the thing, that line, that's our such that, x cannot equal negative 1 or positive 1, close bracket. That's your formal way of writing it. I hate brackets too. I'm not, you see that last one? It really was a struggle. Okay, our interval notation is saying that the function starts at negative infinity, and then you're going to run into negative 1, and you have to stop. I don't know why I'm writing sideways either. We're going to just roll with it too. We're going to stop, and then we're going to go from negative 1 to positive 1, and then we're going to stop again, and we go from 1 to infinity. Ooh. Pen got a little frisky at the end. And again, I have no clue why I wrote it sideways. All right. So the main goal is to find where it's not, where it can't be, right?
Where it can't be.
And as long as you know those, then everything else should fall into place. What? All right. So here we go again. We have determined if the function is rational and state its domain. So we have the cube root of x plus 2 divided by x squared plus 4. Do you think it's rational? No, that's just the function's name. All right. Yes, there we go. I'm pretty sure I did in my previous notes, but I cannot find the completed notes of this section. Are they posted on your thing? I don't think they are. All right, so your numerator. So checking the numerator, our numerator is not a polynomial. Our numerator is x to the 1/3 plus 2, right? That's not a polynomial. Okay. So I believe I put not. At least I would. So it's not rational. No, you can still state the. Yes, it's not rational because of the polynomial. This is not a polynomial in the numerator.
So it can't be a rational function if it's not a polynomial.
So a function that's written as a polynomial divided by a polynomial. So it has to be a polynomial in the numerator and a polynomial in the denominator. I'm going back. I'll take the blame. The thing here is that I didn't emphasize because a polynomial can be just like a 1 or a 2, right? But to be very specific, in the denominator, it has to have a variable, not just a 1, 2, or 3. So I dropped the ball on definition. I take it. So our numerator, is that a polynomial? No, all you have to do is write numerator, polynomial. Okay. We know very well.
I didn't go back and change it.
Okay.
What?
I got it. They already brought it back to me. No, I don't, Miller. I'm sorry. Art? Art? Miss Garrity and 112. Yeah. Mm-hmm. All right. So yeah, so it's not rational. You can still figure out in this where it's limited. However, if I set this equal to 0, I'm going to end up with a negative in the denominator, right? A negative, take a square root. So we're just gonna not rational because it's not a polynomial. Remember, it has to be a poly divided by a poly.
So would any time square root on top of it?
If there's a root. All right. Ready?
Yeah.
So now we're on to example 2. Oh, I just want to emphasize, by the way, because this is what's a face, not a polynomial, not a rational, and x squared plus 4, that's a quadratic. So this would be all real numbers for the domain. Because it's still set to state the domain. Yes, even though it's not a rational function, it still has a domain, right? You'll be a great teacher. Yep. If you're willing to explain. So, yeah, I encourage it. We're a dying breed. Depends on what you're trying to do with your life. Yeah, it just depends on what you're trying to do with your life. All right, here we go. Example 2, of course, it's a word problem. So suppose that a construction zone can allow 50 cars per hour to pass through, and that cars arrive randomly at a rate of X cars per hour. Then the average number of cars waiting in line to get through the construction zone can be estimated by n divided by x. N of x equals x squared divided by 2500 minus 50x. Is that irrational?
Yes.
Yes. Why is it irrational?
Because it has an opening in the front.
You have a poly over a poly, right? All right. Okay.
Bottom and top, that's it.
Okay, so it wants us to evaluate. When it says you evaluate, what are you simply doing? Plugging in, right? Ariel, please put it away. It means that you're just plugging in and evaluating, right? So take a moment and evaluate in a 20, in a 40, and then we'll do in a 49. You plug it in wherever X is, right? So wherever X is, my pen did something very weird on its own. I need room for it in a 49. So I end up with 20 squared over 2,500 minus 50 times 20. What does that give me? And you can leave it as a simplified fraction.
So you don't let us figure it out.
Yeah.
Oh, okay.
So then the other one, again, you're just evaluating, just means to plug in, right? It's the easiest part of it all. I don't know why 8 and 9 are not being correct. That's a very weird looking 49, but it's a 49. You're just substituting for X. So then once you have your exact fraction, then we'll talk about approximating to the nearest. Let's approximate to the nearest 100th. So here we have 20 squared. So if you're trying to put it in all at once, cool. If not, you do your numerator. You get 20 squared is 400. Then you do your denominator, 2,500 minus 50 times 20. And you get 1,500. So you have 400 divided by 1,500, which is what?
So you want to do that? I just let that fraction.
450? That's all I did. If I wanted the decimal approximate value, then I would just do 4 divided by 15, right? And that's approximately 2,700. Sorry. Approximately 2,700. Okay. You also can input it as 1. When you're inputting a fraction into 83, 84, you have to utilize parentheses to represent what's the numerator and what's the denominator. So parenthesis 40 squared, that's my numerator, divided by my denominator, which is 2,500 minus 50 times 40. If I want a fraction, before I hit enter, I'm going to press math. You see where it says proc? And that'll give me the fraction. And I get 16. So then the approximate value here, if I hit enter again, sorry. Second entry. I just don't want that part. I can delete it, I can hit enter, I can type 16/5, but it's gonna be 3 and 2/10. Also, you could do that in your brain. So it's exactly 3 and 2/10. And then you choose which method you want to do for the last one. So for 49, again, I'm going to put it all in, protecting my numerator by putting it in parentheses. And then I'm going to protect my denominator by putting it in parentheses. Okay, if you do not utilize parentheses, then your calculator is going to follow order of operations. Okay, order of operations, in order to make something be done first, we have to use what? The parentheses, right? That's what tells our calculator this needs to be done first before you divide. So we hit enter, and there's the decimal. If I didn't want the decimal, I should have hit what?
Right.
I should have hit frog, right? If I wanted the decimal, I'm gonna hit second, enter, puts it back, and I can do math frog. And there's a very large fraction. So we have 24 divided by 50, which is approximately, or exactly, I think. So looking at the values, what happened to these numbers as they increase? So I went from 20 to 40 to 49. What did their output values do? It did what? Anyone? Anyone? They got bigger, they increased, right? So as I got closer to 50, notice how they increased dramatically. So they dramatically increase. Is that cool if I use that word?
Yes.
Because if I was at 20 and I was only making 27 cents, and then I'm at 49 now, making 48. Okay, how do you feel about evaluating rational functions? Doable? Evaluating is always going to be plugging in and describing.
No, I'm saying, they gotta give us the thingamajig, but we gotta actually read the word problem and look for the thingamajig and stuff.
It'll usually say evaluate. All right, now we're gonna talk about asymptotes. Do you all remember an asymptote? Okay, I'll take that. An asymptote is your imaginary boundary line, right? So the function is approaching, but it'll never touch. Except for horizontal, there are points where it may cross. So we have three types of asymptotes. We have horizontal, vertical, and oblique. If you look right here, you cannot have a graph with oblique and horizontal. You're gonna have one or the other or neither, okay? You can have a graph with vertical and horizontal or vertical and oblique, but you will never have oblique and horizontal. All right, so notice if you look at the graph, this is how it's shaping the graph. So when you're defining it, you're defining what's happening to the graph from left to right. That's your domain, and what's happening to the graph from bottom to top, and that's your range, right? They're your boundary lines. They're your asymptotes. Yeah, they're what you're approaching, but not crossing. All right. So here we have it. We're gonna determine any vertical or horizontal asymptote. So vertical obviously means up and down. Horizontal means side to side. Agreed? So this has it clearly labeled. So if we look here, is there a VA, a vertical asymptote? Yes. How many are there? And where are they? Good job. At x equals -2 and at x equals +2. Why? Because these are counted by twos. Okay. And then are there any horizontal asymptotes? Yes. Where's the horizontal asymptote? -1. Y equals -1. Huh? It's where it crosses the axis. I can't tell you what you need in your notes. Either you know it. Or go back. All right, how do we feel? but literally it's your imaginary line. Okay, so now looking here, are there any vertical asymptotes? Do we see anything restricting it from going up and down? The answer is no. Not a trick question. Now horizontal asymptote. Your horizontal asymptote. So as you look at this graph, what is it doing? What is it trying to approach on both sides? The x-axis, right? So it's trying to approach the x-axis. What is the value of your x-axis? 0. This is y equals 0. So there's a horizontal asymptote. Your asymptotes are going to always be labeled. You have to be able to read the graph and see what is it approaching. So we have a horizontal or h value, or y values, because it goes through the y-axis. So we have at y equals 0 is our horizontal asymptote. Okay, so that's what you're doing graphically. Now we're going to talk about how to do it without a graph, how to identify vertical and horizontal asymptotes. All right, so these are the rules that you follow. I'm going to stop talking and give you a moment to write them down.
All the rules?
Yes. So again, if my shorthand of this thing, numerator degree and denominator degree, I just use n and d. So if n is greater than d, I'm going to have a slant asymptote, which means I'm going to have to do long division. Okay. If I have n equals d, I'm going to have a horizontal asymptote, and all I'm doing is dividing my leading coefficients. If n is less than d, then I'm automatic. I don't have to do anything. I just know I'm going to have a horizontal asymptote at, and I forgot my y. Dang, at y equals 0. Okay, I think we have enough time to do one example. And then we will finish in tomorrow. Okay, in our example, we're going to talk about also how to find your vertical asymptote. Your vertical asymptote is found the same way that we found our domain. It's only focused on the denominator. So our numerator, so in the degree of our numerator is 1, agree?
Yes.
Our d, the degree of our denominator is also 1. So what do we do when n equals d? Okay, so we know that it's a horizontal. Reason being, what do we say? If n equals d, it's going to produce a what? Horizontal asymptote. How do we find that? Divide the leading coefficient. So my leading coefficient in the numerator is 3. Agree? And the leading coefficient in the denominator is -2. So my horizontal asymptote is at -1/2. This is your horizontal asymptote. All right, and then last, your vertical. So to find the vertical, all it is based on your denominator. By taking your denominator and setting it equal to 0. So vertical is your denominator set equal to 0. So we have 1 minus 2x equals 0. I'm going to subtract 1 and divide by -2. So what does that equal?
1/2.
1/2. So my vertical is at x equal 1/2. So here's my vertical asymptote. And my horizontal. Right. We will continue example 4. And we have A few more to do tomorrow.